Hello everyone, I'm Dinesh Verma, IBM Fellow and Fellow of UK Royal College of Engineers. Today I'm here with Professor Elisa Bertino of Purdue University to discuss Natural Language Interaction Protocol, NLIP, an exciting new technology which applies generative AI to transform protocol design. Elisa is the Samuel D. Conte Distinguished Professor of Computer Science and Director of Serious at Purdue University. She is one of the foremost security researchers in the computer science community.
Thank you, Dinesh. It is great to be with you today. I have enjoyed working with you as an eminent industrial researcher in computer communication network to define a revolutionary new application level protocol, which we have called NLIP. Dinesh, can you describe what NLIP is?
Oh, definitely. NLIP is designed to mimic how humans communicate. Just like we have organs for different type of senses, like our eyes for vision, our ears for hearing, and we can use these to communicate in many languages, many modes, show pictures, gestures. NLIP specifies the format of information that computers can use to communicate with each other. We use AI technology to interpret that information locally. This approach improves interoperability between client software and server software. NLIP is being designed by several universities and companies working together, and it is being standardized by ECMA.
What is ECMA and why does it make sense to standardize NLIP via ECMA?
So ECMA or ECMA stands for European Computer Manufacturers Association. It is a non-profit organization that develops and publishes standards for application level technologies such as ECMAScript, better known as JavaScript, Dart, and OpenXML. It is a natural home for standardizing an application level protocol like NLIP that solves a very specific problem.
Yeah, this is so true, Dinesh. Today, we face a major problem. We have many different application level protocols, each one of them corresponding to a different API. Therefore, all those API result in a very significant complexity when combining different services together. Often, for example, a server is upgraded to define a new version of the API, which in turn requires a new client-side component. NLIP provides a major, important, groundbreaking capability which would allow any client application to talk to any server. Dinesh, can you elaborate on how the protocol achieves this goal?
Sure, the protocol applies the technology of generative AI to design a universal application level system. The idea is that we decouple the information that is flowing on the wire between two computers from the internal representation of the information on both sides on both computers. From the information that flows in natural language on the wire, each side uses a generative AI model, a large language model, to translate that wire representation to an internal efficient structure representation that each party would use.
Yeah, this is very exciting. I want to mention a very important aspect. Since each side will use a generative AI model to do the translation on the other side, NLIP is very well suited for artificial intelligent agent to agent communications, which today is a new important technology which has been being developed. On one side of the communication, the agent can be real intelligence that is a human, or can be really another agent which is not a human.
Oh, yes, indeed. And what this approach allows is that any agent can talk to other agent in a very flexible general manner. An agent on one side can be upgraded to a new version, and it doesn't require the protocol or the client other agent to change, which means that if you have to build a multi-agent system, you can switch the order around in different ways, combine them in new complicated graphs, and obtain a highly enhanced degree of interoperability.
Yeah, this is great. And something I want to mention is that this protocol has been designed with security as a first principle in mind. And we have a special group within the standardizing committee for NLIP, which is making sure that most security challenges are addressed properly, also providing a lot of very good practices that developers can follow. Dinesh, when is the protocol going to become official?
Okay. Our plan is to submit this protocol definition for formal approval to ECMA General Assembly meeting, which will happen in December 2025. So on the publishing of the proceedings, it will be an official standard with all official documents effective January 2026.
But aren't we working with another open source groups in addition to ECMA?
Oh, you're so right, Elisa. Yes, in addition to the ECMA process, we have a parallel track which is happening in an organization called the Enterprise Neurosystem Group. It is an open source consortium which is trying to define systems for a universally connected planet scale AI network. The ENG group, Enterprise Neurosystem Group, meets once a week, and it also allows participation from non-ECMA members. So that way we get feedback from a much more broader audience. This project has also been adopted as a sponsored initiative of AI Alliance, which is a collaborative network of more than 180 organizations building and advancing AI technologies.
Okay, so this is really great. And for people who are interested in more information, we have a website describing the protocols, use cases, and other related documents. And please visit the website www.nlp-org.
Thank you, Elisa, for joining me today. And thank you to everyone if you are listening to us today. We both invite you to join the effort for defining, using, and promoting NLIP. In the description of this video, you can find some useful links for further information. Thank you.